All right. While you guys are pulling that out, we are going to go ahead and start going over the bell work. So first thing I want to do is take it into general form. Again, general form is our ABC form. And this form is the one that's considered to be fully simplified. There's no parentheses at all. So as long as we still have any parentheses, we are not fully in general form. Order of operations is what we have to follow in order to get rid of the parentheses and put it into general form. We have parentheses, but when I look inside those parentheses, there's nothing that I can actually do to simplify. So I don't have anything to do in this step. We do have an exponent, though, that we're going to need to take care of, and that's right here. What does it mean for something to be squared? Yep, you have to multiply it by itself. And it's the parentheses that are squared. It's not the x and the minus 4 all by themselves that are squared. It's the whole set of parentheses. So I'm going to write it down 2 times. And I'm going to keep that minus 1 out at the back too, just so I don't lose track of what I'm doing here. So this is what we're focused on first. We are multiplying these 2 pieces together, so we have to use the distributive property. And because in front of the second set of parentheses, so right over here is where I'm looking, this first x minus 4, because there's 2 pieces in there, I have to distribute both of those pieces to the second set of parentheses. So I'm going to use double distribution to do that. I take my x and I distribute it to both pieces. And when we distribute, what operation are we using? What are we going to do with these pieces? Multiply. X times another x gives me x squared. X times negative 4 gives me minus 4x. And then I'm going to take the negative 4 and I'm going to distribute that as well. So I get another minus 4x. And then what happens when I do negative 4 times another negative 4? It becomes a positive. Positive what? 16. Positive 16. And then I'm going to bring down the minus 1 from the end here. The last thing I need to do on this is to combine any like terms. There's nothing else that I need to distribute. What are the like terms that I want to be putting together here?
The negative 4x, negative 4x, and then you have to do 16 plus 4 minus 1.
Yep. So these are the pieces we're going to combine right here. So my general form, I'm going to use function notation since that's what they used in the original problem. But remember, if you guys forget and you put a y equals there, I'm never going to take off points for that. So I have f of x equals, thank you, sir. Start with x squared. When I combine the negative 4x and the negative 4x together, what do I get? Negative 8x. And then 16 minus 1? 15, positive 15. There's my general form. That's the form that I'm going to take to begin putting things into factored form. Now, factored form, when I'm all done with that, yep, we have our a out at the front. This one is going to have 2 sets of parentheses, and it tells me where my roots are, my x-intercepts. So I'm starting from this point. I'm going to identify my A, my B, and my C values. What are the A, B, and C values? Yes. So A, the coefficient in front of it is a positive 1. B is negative 8. C is positive 15. Am I going to be able to use my shortcut here?
Yeah.
Yes. How do we know when we look at it? Yep. I'm looking right here, right here. I can use my shortcut. Shortcut means I still have to use the x, I just don't have to use the whole box. So I'm going to draw the x. Up on top, I'm going to multiply the a and c coefficients together. So I'm multiplying 1 and 15. I need two numbers that when I add them, I get a positive, or sorry, when I multiply them, I get a positive 15. When I take those same two numbers and add them, though, I get negative 8. So what numbers will do that? Negative 3 and negative 5. Since it multiplies to give me a positive, I know they have to have the same sign. They're either both positive or both negative. Since I know it has to add to a negative number, that told me they had to both be negative there. So here's the two pieces that I've got. So I'm going to have f of x equals, because there was no GCF, what is my a value? 1. And then I'm going to have my two factors. What letter do I have to put inside each factor? X. And then those two values that we found in the x, those are the pieces that go inside these parentheses. So it's going to be x minus 3 and x minus 5. Now I'm curious, before we go on and finish up the notes from Friday, can you guys tell me where the y-intercept would be now that we have all three forms? Not for my y-intercept. Which form do I look at for the y-intercept? Yes, ma'am. We look at general form for our y-intercept. Yep. So if I write the whole ordered pair for my y-intercept, it would be 0, 15. Where is the vertex? 4, negative 1. We look up at our vertex form. This would be 4, negative 1, because remember we want h and k for this. What I see in here is the opposite of h. And last but not least, where are my roots? X equals 3 and x equals 5. So x equals 3, we could write as the ordered pair 3, 0. And x equals 5, we could also write as the ordered pair 5, 0. Just depending on how they ask you to give your answers back. Awesome. Let's go ahead and pull those notes out again. Hopefully everybody has located them. We left off on Friday. We had just done problem number 4. Nope.
No.
Not done with the book. Remember, I used these on Friday because a lot of this stuff, almost word for word, is in your book, but it's scattered over like 5 different pages. And so you guys were going to have to be flipping all over the place. And then the pictures for the graphs that we're getting ready to do here in a minute didn't show up very well. It was hard to see them. So I went ahead and printed something else out for us. We did number 4, part A, on Friday, right before the bell. This is exactly like our bell work that we just did. I want you guys now to take the general form that we got in part A, it's written there in blue, and I want to factor it, just like we did on the bell work. So I want you to pick it up from there, label your A, B, and C, check to see if you can use your shortcut, write it in factored form, and see if you can identify your roots. I'm going to give you guys about 3 minutes or so to do that. All right. What are the A, B, and C values here? 1, 6, and -7. So we've got our A here, our B here, and our C here. Can we use the shortcut on this?
Yeah.
Yes. I see that this is 1. So I'm only going to have to use the X. You're welcome, sir. Thank you. We are on the notes page that we started on Friday. So we would multiply our A and C values together. That means I'm multiplying 1 and -7. I need 2 numbers that will multiply to -7, but that will add to a +6. What's going to multiply to -7, but add to a +6? -1, +7. Because when I multiply those two together, negative times a positive, I get that -7 there. When I add them, because the 7 is bigger, that's 7 minus 1, so that gives me a +6. So factored form, I would have y equals what? X minus 1 and x plus 7. To use that to find the roots, which is the very last part of this question, what do I do with my factors to find my roots? Set them equal to 0. So I have x minus 1 equals 0, and I have x plus 7 equals 0. So then on x minus 1 equals 0, I would add 1 to both sides. I get that x is +1. So that ordered pair would be +1, 0. You can write that as x equals 1, or you can write that as the ordered pair. Depending on how I'm asking for your answers back on Canvas will determine whether you write it as an ordered pair or as an x equals. So just pay attention to whether or not it has an x equals there for you already. When you go to take the test, unless I have clearly indicated which one I want, I would accept either one as correct because they have the exact same meaning. And then for the other one, x plus 7 equals 0. What would I do there? -7, yes. -7 from both sides. So x is -7. So that means my other ordered pair would be -7, 0. All right, let's go do part B. Part B is a little bit more challenging than part A because what else do we have to pay attention to here? We've got the fraction out in front. What's happening between the fraction and the parentheses? What operation is happening? Multiplication. So I'm going to go ahead and just write it in there so that I see it. Thinking about my order of operations, we're going to start with parentheses, which I do have, but can I do anything with x minus 6? Nope. So I can't really do that, but I do have exponents. So this is my focus right now. I'm not dealing with that -1/2 at all at the moment. So I'm going to leave that -1/2 out front. I'm going to write down what it means for x minus 6 to be squared. That means I'm multiplying it by itself. I'm focused just right here. And then plus 2. Double distribution. So I take my x and I distribute it to both pieces. That would give me x squared minus 6x. And then I take the -6 and distribute it to both pieces. So I have another -6x. And then -6 times -6 gives me what? Positive 36, yes. Now all of that was being multiplied out in front by that negative 1/2. So after I do my double distribution, I would move on to multiplying that negative 1/2 to everybody. So I'm going to distribute that just to the pieces inside the parentheses. That +2 was never being multiplied by the 1/2. So I'm going to distribute this. If you want to combine the negative 6x and negative 6x first, you can, but you don't have to. When I multiply x squared by negative 1/2, I get negative 1/2 x squared. Negative 1/2 times negative 6. Well, negative times a negative gives me what? Positive. What's half of 6? 3. So this would be plus 3x. And then I distribute the negative 1/2 to another negative 6. So again, I've got negative times a negative. That gives me a positive. Yep, it's going to be a positive 3x because remember, negative times negative. But yeah, then it's half of it. What's half of 36? 18. This is going to be minus 18. Because this time I didn't do a negative times a negative. And then I have that +2 on the end. Do I have any parentheses left at all? No. We're almost done. The last thing I need to do is what? Yep, we're going to combine our like terms together. So I'm going to combine the two 3x's together. And I'm going to do negative 18 plus 2. That will put it into general form for me. So I have k of x equals negative 1/2 x squared plus 6x minus what?
16.
Minus 16. It's okay. Now that we have it in our general form, I can identify the y-intercept from here. What would the y-intercept be? 0, negative 16. Right here is.
The vertex is going to be positive 6 plus 2.
Yep, positive 6, positive 2 for our vertex. That's absolutely correct.
It's in the H class.
Mm-hmm. We have our H and our K. Here's K. And this guy is the opposite sign. Perfect. I'm going to skip putting this into factored form for right now because I want to look at those graphs. These graphs are packed full of all kinds of stuff. This is really my opportunity to see how much you understand from everything that we've done. Because from our graphs, we can use that and the information that we can pull from it to write all 3 forms and give some other information. So looking at this, the first thing I want to pick out is the vertex. What is the vertex?
The vertex is negative 3.
Yep. Negative 1, negative 4 down here at the bottom. There's our vertex. I want to use that to begin to write my vertex form, but what's the little reminder that they gave me up at the top? It's inside parentheses. Find the A value. So I'm thinking about my vertex form. Y equals, this is my AHK form. I've got 2 pieces of that right now, don't I? Which pieces do I have? I have the H and I have the K. So I can start to write my vertex form. I can't finish it because I don't know what goes right here. If you're writing in pen, I would leave that space blank. But I can fill in this piece. It's going to be x plus 1 or minus 1?
Plus 1.
Plus 1, because inside my equation, this is the opposite. And then what will I have at the end? It'll be minus 4 because k is a negative there. So I'm going to use this right here. We're going to find our a value. I'm going to use this open space down at the bottom. So I have y equals, I don't know what my a value is, but I know the x plus 1. Oops, I forgot to square those parentheses. Really important. When we were working with a table and we had it at this point, we went and picked out another ordered pair off the table, something that was on that parabola. So I want to find some other point that's on this parabola. We could use the roots.
0, -3.
Yep, we could use the y-intercept if we wanted to. Any other point that you can clearly pick out off this parabola, we can sub in for x and for y. What point do you guys want to use? 0, -3. That's our y-intercept right here. We're going to use this to find a. And there's nothing special about it being the y-intercept. It just needs to be a point that's on your parabola that's not the vertex because we've already used those numbers. Where would I put the 0 in this equation? That's going to take the place of which part? X. That's the x part of my ordered pair. And so I put 0 in the place of the x. So I would have 0 plus 1 squared. We're trying to find the a, so I still have the letter a. What's going to take the place of the y? -3. Because that's the y part of my ordered pair. And now I'm going to simplify. Order of operations says to do what first? Parentheses. What is 0 plus 1? 1. So I have -3 equals a times 1 squared minus 4. What's 1 squared? 1, because we do 1 times 1. So I would have -3 equals a times 1 minus 4. A times 1 is just 1a, which I can just write as a. And then what do I do to get a by itself here? Add 4 on both sides. So what value are we using for a here? 1. So when I'm thinking about my vertex form, I know now that a equals 1. Do I need to write that in there? No. I can if I want to, but if a is 1, you don't have to write it in. So that would be my vertex form right here. Let's do the roots in the factored form. Where are my roots?
-3 and 1.
Yep. Over here, that's the ordered pair -3, 0. So we have x equals -3. Over here, that's 1, 0. So x equals a positive 1, and these are both roots. So does that mean that it's going to be x minus 3 and x plus 1?
No.
No. Factors have to be equal to 0. So I'm going to take this x minus 3, or sorry, x equals -3. And I want to make it equal to 0. So what would I need to do to both sides to make that -3 cancel? Add 3 to both sides, yes. So I get x plus 3 equals 0. It's equal to 0. So that means this is my factor. So I'm going to write down my roots, and then we're going to start writing factored form. So I had x equals -3, x equals +1, but for my form, I would have y equals x plus 3. What's my other factor going to be? X minus 1. Because I have x equals 1. I would subtract 1 from both sides to make it a 0 over there on the right. X minus 1 equals 0, so here's my other factor. Do I need to worry about an a value in the front? Why or why not? A is 1. We already found A, and that's going to be the same A for every single form. So once we find it once, we can use it for all of our forms. General form. I have to either use my vertex form or use my factored form to find this. When I'm given the choice, I usually think it's easier to use factored form because I don't have to worry about a squared anything there. So I'm going to take our factored form, and I'm going to use double distribution to put it into general form, just like we've been practicing. Give myself a little bit of space to do this in. So I'm going to recopy it. Y equals x plus 3 times x minus 1. When I do x times x, what do I get? X squared. X times -1 gives me -1x, or minus 1x. Then we take the 3 and distribute it. What is 3 times x? 3 times x? 3x. Then I do the 3 times -1. Don't forget you got to distribute to everybody, so we're going to end up with 4 pieces. Here's where that -3 comes in. What like terms do I need to combine together? Yep, -1x and a positive 3x. What do I get when I combine those? Positive 2x. That's all the pieces that I need to write my general form now. I would have y equals x squared plus 2x minus 3. Where is the y-intercept? -3. So 0, -3. The y-intercept, I do want you guys to always write this one as an ordered pair. Just like with our vertex, we always write that one as an ordered pair. What is the domain for all parabolas? -infinity to infinity. What that means, because remember the domain is telling me what I'm allowed to use for my x's. This notation says I can use any negative number, I can use any positive number. There's no restrictions. It's the same thing as all real numbers. My range has to do with my y's. We're always going to have a minimum and a maximum. We have a minimum on the graph. That vertex, see how it's the lowest point? That vertex is a minimum. So I want the y part of that ordered pair. What's the lowest this parabola ever goes? -4. And I'm going to use a square bracket there because we actually do have a dot there. It's possible for me to put a dot on -4.
Oh, that says?
Mm-hmm.
Actually, no more specific, like, you get the bracket or the parentheses.
Yes, but I won't take off points. I'll correct it. Later on, when we do like a full day lesson over this notation, from that point forward, then I would start to take points off if you don't. But for this one, if you forget and you put parentheses, I would just correct it and not take off points.
For range, always.
Hmm?
Always brackets, correct?
Yes, on our range, we're always going to have a bracket around the number part.
And you would have parentheses.
Mm-hmm. Why am I going to have parentheses at the end? What's going to go after the -4?
I mean, like,
Look at my graph.
-1?
What's the highest this ever goes? Infinity. Because those ends, even though this graph, because I pulled it off of the internet, doesn't have the arrows on the end, we know that it really has arrows there. It's going to continue going on and on and on forever up.
So there was another point, they didn't have something to stop it?
Yeah, like if there was a curve at the top, yes.
Okay, so.
Yes, ma'am.
So if it's a maximum, start with infinity.
If we have a maximum, so if this thing was turned upside down, you would start with -infinity, because the arrows would be pointing down. So the lowest would be -infinity, all the way up to your maximum. And that would go here.
Which is the vertex.
Yes. Now on this one, because it's facing up, it has a lowest point, a minimum, and then it goes on forever pointing up. Mhm. It's always going to be smallest and then biggest. Minimum and maximum. Where's my axis of symmetry? Give me the whole equation here.
X equals -1.
X equals -1. It's always going to cut my parabola in half. So it's always going to be x equals whatever my h value is, so that I can cut that parabola right in half. Fantastic. Let's look at one more like this. I want to do the one at the bottom of the page, the one that's upside down. So we're going to do number 5, part C. Let's do this guy. Where is this vertex at?
Negative.
Mm-hmm. There's our vertex.
The vertex
-1 what? -1, 0. That's interesting. Anytime my ordered pair has a 0 in it, I know it's going to be an intercept, either an x-intercept or a y-intercept. Which axis is it touching? The x. This is also a root. X equals -1. Are there any other roots? No. No other roots. When I have two features that are exactly the same, like in this case it's the vertex and the roots, that means these two forms are going to be identical. If they have the exact same ordered pair for the feature, they're going to have the exact same form. So I've got my h and my k. I'm going to start writing my vertex form, which will be the same as my factored form. I don't know my a value yet. What's it going to look like inside the parentheses, though? X plus 1 squared. What will I have at the back? 0, because why? Yeah, that's the k part of my ordered pair. If you add 0 to something, you have $5 in your pocket, and I'm going to add $0 to what you have. Does it change?
No.
What about if I subtract 0?
No. Doesn't change.
It doesn't change. So I don't have to write a +0 or a -0, because it's not going to change it at all. Still don't know that a value, though. I'm going to need to substitute a point in to figure it out. Pick out some other point off this parabola that we could use.
-2 and
This guy right here?
-2 and 0.
Yep. What does that ordered pair look like? Because which part is the x and which part is the y is really important.
It's going to be 2. It's negative 2 and 0.
0.
Because in an ordered pair, which piece always comes first?
X.
The x. That tells me from the origin how far left or right I moved. From the origin, From right here, we didn't go left or right at all to get to that point. We just went down 2. All right, so I'm going to substitute in here. What do I put in the place of the y? Negative 2 is equal to a, and then what are we putting in the place of the x? 0. And then I've got plus 1 and squared. 0 plus 1 is what? 1. So I'm taking 1 and I'm squaring it. It's going to be what? Just going to be 1. So negative 2 is equal to a times 1. And a times 1 is what? Yep, 1a. So this is negative 2 equals a. There's my a value. Does that make sense with what we see on the graph? What kind of an a value were we expecting? Positive or negative? Why? Because it's going down. So what's my factored form then? Yep. Y equals negative 2 times x plus 1 squared, because the vertex and the root were exactly the same. If they were different, then I'd have to do it like I did on the other problem. General form. Have to pay attention to the exponent first. What does it mean for something to be squared? Multiply it by itself. So I have x plus 1 being multiplied to another x plus 1, and this is where we're going to start. So double distribution, x times x, x squared. X times 1 is just 1x, but then I have to take the 1 and distribute it also. So I have another plus 1x and plus 1. And all of that is still being multiplied by what? Negative 2, that a value out in front. We have to distribute that to everybody and then combine like terms. So I have negative 2x squared minus 2x minus 2x minus 2. What do we get when we combine our negative 2x's together? Negative 4x. So I have a negative 2x squared minus 4x minus 2. What's my y-intercept? 0, negative 2. What is our domain? Negative infinity to positive infinity. Here's a chance for us to look at a parabola that's facing upside down. What's the lowest this parabola ever goes? Negative infinity, because it's going down. What's the highest y value? Is that the y part of the ordered pair? 0. This is our k value. Axis of symmetry, and then we're done. X equals positive 1 or negative 1? Negative 1. Because our h is negative 1. Nice work. Ladies and gentlemen, homework 7 is due tomorrow. We've covered everything that you would need to be able to do that one. Hopefully you started that over the weekend because it is a long one. Your test is this Friday. I want you guys to view homework 7 as kind of like your first review for that test. Tomorrow we're going to look at applications. So where do we actually use this in the real world? And then Wednesday and Thursday we'll review for your tests.